Hello everyone, today we are going to explore about the off-center force in high-field magnet. In this video, we'll cover three key topics to explain the concepts of off-center force. First, we'll discuss what off-center force is and why it's important. Next, we'll provide case studies considering different scenarios. Finally, we'll discuss the issues related to off-center force in practical magnets. Let's consider a situation with two solenoid magnets, one placed inside the other. Ideally, if the centers of both magnets are perfectly aligned, the Lorentz force acting on each magnet will cancel out, resulting in a net force of zero. However, imagine if the inner magnet is displaced from this central alignment. As we can intuitively understand, this situation will cause the net force on the magnets to no longer be zero. The force that arises from this misalignment is referred to as the off-center force. This force can lead to instability and requires careful management in practical magnet applications. Off-center forces typically arise when there is a misalignment in the central positioning of magnets, or when the axes of two magnets do not align correctly. Additionally, in case 2, within a single magnet, off-center forces can also occur at the individual pancake level. In this case study, let's visualize off-center force by considering a scenario with an external magnet producing 8 Tesla and an internal magnet producing 35 Tesla. We will examine what happens when the internal magnet is displaced axially. The case study features a graph that displays the axial forces exerted on the internal magnet as it is moved. In high magnetic fields, 5 cm displacement can result in off-center forces of several kilonewtons. This significant force from such a small displacement illustrates the sensitivity and potential challenges in managing magnetic systems in high-field environments. Similarly, when the magnet is moved in the radial direction, even a small displacement can generate significant off-center forces. When the axes of the magnet are tilted, substantial torque can be induced as well. The following animation is provided by Dr. Kwangmin Kim, a superconducting magnet engineer, regarding an actual mechanical failure of an Ni-class magnet. As illustrated in the animation on the right, a quench occurred within the magnet, resulting in an upward force acting suddenly on the magnet. During this situation, the bolt structure preloaded and the current led were damaged. As can be seen in the middle photograph, the off-center force like this led to significant damage to the structures. To summarize today's discussion, we have explored the concept of off-center force and examined several case studies along with practical case of damage due to the off-center force. We discussed how even slight misalignments can generate significant forces, leading to substantial forces enough to break a structure. This highlights the critical importance of precision in the alignment of magnetic systems to ensure their stability and efficiency.